Hello friends, welcome on differential calculus. In the previous lecture, we had done differentiation of parametric functions. In this lecture, we are going to do logarithmic differentiation. Okay, so what kind of problems we are going to do under logarithmic differentiation? Now let us go back to exercise 8a. In this exercise, come to question number 24. Look at this question. X bar y into y bar x is equal to m, where m is constant, then dy by dx is equal to what? Let me repeat. X bar y into y bar x is equal to m, where m is a constant. This number m is a constant. Like I've told you earlier, no? These are general. These letters are generally used, like m, n, a, b, c. These are generally constants. For example, in this question, g and h. These are constants. Okay, because x and y are variables, anything else other than this which is used in this question would normally be constants. And in CA foundation syllabus, you have only differentiation with two variables. You don't have three. So you don't have to expect to see a z in the question. You can expect only a x and a y. Okay, so now we have x bar y into y bar x is equal to m. And the question is asking you to find the value of dy by dx. Now let me write this question down. This is question number 24. X power y into y power x is equal to m. Dy by dx is equal to question mark. Now why did I choose this question under logarithmic differentiation? I chose this question because look at the first term, a variable. X is a variable, power y is also a variable. Then you have multiplied with y, which is a variable. Again, it is raised to the power of x, which is also a variable. So you have variable power variable. So far you have done question x power n, variable power constant. You have done a power x, constant power variable, right? So this is a variable, this is a constant. Now this is a constant, this is a variable. Correct? Now this is the first time you are doing x power y variable, power is also a variable. Now in these cases we will use logarithmic differentiation. I hope it is now clear when to use logarithmic differentiation. So in the examination also, whenever you have questions of this type, variable power variable, you will use logarithmic differentiation. Now in this lecture, it will become amply clear to you what are the questions that I have chosen out of the 50 questions. Okay, there are only 3 questions totally. All the 3 questions I'm going to do for you in this lecture. So you will be very, very clear which are the problems that you must select to apply logarithmic differentiation. So what do we do on the next step? Taking log on both sides. Okay, taking log on both sides. How do you take log? You do log of x power y into y power x is equal to log m. Now base is going to be e. Okay, the base is always e, needless to say that. Now what is the property that you have learnt? Log a into log b, or rather we have learnt with m and n, right? So let me use the same letters. Log m into log n is equal to log m plus log n. Let's apply this property here. Log x power y plus log y power x is equal to log m base e. Now we have learned the property log a power m base e is nothing but base e or b or any other base. Any base you want you can take. M log a base b. We've learned this in logarithms chapter. The power m comes out. This power m has come out. Okay, so here this power y will come out here. So y log x plus x log y is equal to log m base e. Now you need not write the base at every stage. It is not necessary. It is understood. Now at this stage I am going to differentiate both sides. Differentiating both sides. How do we differentiate? Two functions. Y is one function, this is another function. So let us go back to product rule. What does the product rule say? Product rule is when we differentiate d by dx of uv, it is nothing but uv dash plus vu dash. Okay. Y into log x differentiation is 1 upon x plus log x into differentiation of y is dy by dx plus the same thing for this, x into differentiation of log y is 1 upon y dy by dx plus log y into differentiation of x is 1. Okay, so now what we have is, look at the two dy by dx terms. Okay, actually there's no need for a bracket here. I don't know why I happen to put a bracket. We can just say this is equal to, the right hand side we have log m. Log m is a constant, so when we differentiate a constant it becomes 0. So here we will take dy by dx common, open the bracket, log x plus x upon y, close the bracket. Now the remaining terms, you can take them to the other side with a negative symbol, open the bracket, log y was one term, the other term is this, plus y upon x, close the bracket. Now the next step would be is to take LCM. Y log x plus x divided by y, close the bracket, write down dy by dx is equal to minus x log y plus y divided by x, close the bracket. Now dy by dx is equal to, bring this term to the other side. What happens when you do that? Minus x log y plus y remains as it is. Now in the denominator I am going to write this term, y log x plus x, close the bracket. This x remains as it is here, and in the numerator this y comes here. So this is what is the result of your differentiation, the value of dy by dx. Okay, so now let us go to the option and let's try to match it. So it's matching exactly with this option B. Okay, so answer is option B. Next, I'll give you 2 minutes for you to be able to browse through the questions and select any logarithmic differentiation question. Question number 33. Question number 33. Now look at the question. It is a plus x divided by 1 plus x. So the base is a is a constant, 1 is a constant, but x is a variable. So a plus x becomes a variable, denominator also variable, so this entire term becomes a variable. And the power is a plus 1 plus 2x. So the power is also a variable. So variable, power, variable, therefore we will differentiate it with logarithmic differentiation. So now let us write down this question. F of x is equal to a plus x divided by 1 plus x, the whole thing raised to the power of a plus 1 plus 2x. The value of f dash of 0. F dash of 0 is question mark. Okay. That is, you have to find the value of f dash of x at x is equal to 0. So find f dash of x first, then substitute x equal to 0. How do we do that? Now, instead of f of x, you can take the letter y here. It becomes easy to do. taking log on both sides. So you have a log y here. On this side you have log of a plus x by 1 plus x, whole thing raised to the power of a plus 1 plus 2x. Now the property that we learnt, log of a power m is equal to m log a. Let's apply that property. Let's take this power out. A plus 1 plus 2x, when we take out, what remains is log of a plus x by 1 plus x. Okay. Now in all these logarithm questions, it takes a lot of time for us to simplify before we actually start differentiating it. But the moment we simplify it, the differentiation becomes very easy. So it is a simplification which takes a lot of time. And for that, you must remember the properties very, very well. Now, what is the next property? Log m by n is equal to log m minus log n. Please practice these questions adequately. Only then it becomes easy to identify a logarithmic differentiation question in the examination. A plus 1 plus 2x, you keep it as it is, open a bracket, write it as log of a plus x minus log of 1 plus x, close the bracket. This side you have a log y. Okay, now is when we are going to say differentiating both sides, because now we can easily apply the product rule. Okay, so on the left hand side what you get is 1 upon y dy by dx equal to product rule. So a plus 1 plus 2x, we will keep it as it is, and then we will differentiate this term, which is 1 by a plus x minus 1 by 1 plus x, close the bracket, plus this term is going to be written as it is. So take the big bracket, log of a plus x minus log of 1 plus x, okay, multiplied by a plus 1 plus 2x, close the bracket. Okay. Okay. So this is what we have. Now next step is we have differentiated. We have to find at x is equal to 0. What the question is asking is f dash of x at x equal to 0. So now let me come to the left hand side a little later. Okay, so I have the f dash of x term here, but I also have a y term. I'll come to that later. Come to the right hand side first. Wherever there is a x, you substitute 0. Okay, so what remains? A plus 1, open the bracket, 1 by a minus 1, close the bracket, plus log a minus log 1 into a plus 1. Okay, now all of us know that log 1 value is 0. So now first term and second term, what is common? A plus 1 is common, so take it out common. What will remain is 1 minus a by a. Then I take LCM here, and what will remain from here is plus log a. So let's keep this as it is. Now this is the value of dy by dx multiplied by a y. Now before I write y here, let me go back to my original question and write what is the value of y. Y is nothing but a plus x divided by 1 plus x, whole thing raised to the power of a plus 1 plus 2x. Now since we are finding it at x is equal to 0, what we would get here is y is equal to a power a plus 1, because this term becomes 0, this becomes 0, this becomes 0. So what remains is a by 1, which I have written as a. In the power, this becomes 0, so a plus 1 I have written it as it is. Okay, so now we have to, this y multiplied by 1 upon y comes to the other side. So what happens when it comes to the other side? It becomes a raised to the power of a plus 1, okay, multiplied by a plus 1 multiplied by 1 minus a by a plus log a. Now at this juncture I am going to look at the options and see if it matches, else we are going to simplify this further. Look at the options. So this is what you have in the option. I'm ignoring this term and this term because we know our answer is kind of closer to this. So what do we do to this? Let's come back to our question. This seems more possible, a power a plus 1. So do we have that? A power a plus 1 matches. Okay. Next. So this, can we take it inside the bracket? I'm sorry, there is just one small correction here. When we used a product rule and we differentiated both the sides, this part was okay, and the second part we retained and we should have differentiated this. I think I missed to differentiate this. I'm sorry about that. So let me just rewrite this. A plus 1 would vanish, right? And what you would have here is only a 2. No wonder we were getting that extra term. So what you would have here is only a 2, not a plus 1, only a 2. So here what you would have is 2 log a. Okay. I think now it's clear. So let me just rewrite this step. So it is just, when we bring the y to this side, a into a plus 1, put it within a bracket. This, when we multiply with this term inside, 1 plus a into 1 minus a plus b into a minus b is equal to a square minus b square. So this, what you get here is a square minus, or rather 1 square minus a square, because 1 is first. So what we would get is 1 minus a square by a. Okay, put this within a bracket, plus 2 log a. You can write it as 2 log a, or what you can do is log a square. Now let us look at the options and see if this matches. So what you have is exactly matching here. Okay. So let me just go back to the step where there was a mistake. This was the place. I hope you all have noted it down. I did not differentiate this. Okay. The product rule says, that's why it's good to always write the formula. Differentiation of uv is equal to uv dash plus vu dash. Okay. So u, this was my u term and this was my v term. So I wrote uv dash here and then v into u dash. U dash is differentiation of this, which I did not write. I wrote the term as it is. So now I'm correcting it. I'm differentiating this term. A is constant 0, 1 is constant 0, 2x differentiation only 2. So now this is what we have here. Okay. So answer is option B. Now let us go to question number 46. This is the question. Y is equal to root x power, so on up to infinity. Then what is the value of dy by dx? Okay. Now let us just look at the options. All the options have a y square in the numerator and the denominator has some 2 minus y log x or just log x or something like that. Just have this roughly in your head so that when you're simplifying you will know how to take LCM or what we should do. Let's write down y is equal to root x power root x, okay, so on up to infinity. The meaning of this, I think this we have done in equations chapter also. What we have done in equations chapter is you had a problem where you had something like this, 1 by x plus 1 by x plus 1 by x. We had something like by x plus 1 by x plus 1 by x, something like this, so on up to infinity. So what this means is, suppose I eliminate this part. Suppose I just eliminate this part, okay, what happens? You're left with the same thing. Suppose I eliminate this part, you're left with the same thing. So what this means is, I can say that this whole part which I'm eliminating now is nothing but y again. It's nothing but y. Now the question becomes simpler for us to start solving, right? So this is what we are going to do in this question also, okay, because this is nothing but root x power root x power root x power root x. It goes on like this up to infinity. So what do we do with all these powers? We are going to call all of this as y, okay, because y is nothing but root x. Okay, so next step is y is equal to root x power y. Now after doing this, it must be amply clear to you why this is chosen under logarithmic differentiation, because the base is a variable, the power is also a variable. Now we will do taking log on both sides. So log y is equal to log root x raised to the power of y. Okay, now the property of log a power m is equal to m log a. So this is nothing but y log root x. Okay, so now let us, root x also can be written as, root x is nothing but x power half. Root x is nothing but x power half. This can be written as, this half can also be taken out. So when I take out this half, the half would come here. It would be something like half y log x. Okay, this becomes easier. Now we can take the 2 to this side, then it becomes even more easier for us to differentiate. So it becomes 2 times log y equal to y log x. Now let's apply the product rule on this side, and this side would be the regular differentiation. So let's write down differentiating both sides with respect to x. Okay, so now keep the 2 constant as it is. Log y differentiation is 1 upon y dy by dx, and on this side you have y into differentiation of log x is 1 upon x plus log x into differentiation of y is dy by dx. Okay, now let me combine all the dy by dx terms, this term and this term, bring it to this side. So what you have is 2 by y minus log x within a bracket dy by dx is equal to y by x. The next step, let's take LCM here. 2 minus y log x divided by y into dy by dx is equal to y upon x. Now the question was asking us the value of dy by dx. Dy by dx is equal to y, and this y, when it comes here, it becomes y square. Then in the denominator we are going to have only the x and multiplied with this term, 2 minus y log x, close the bracket. So this, let's check which option matches with this. Y square was there in all the three options. Let's just look at the denominator to match it. X into 2 minus y log x, option B. Okay, so these are the three problems under logarithmic differentiation. In the next video, we'll be doing questions on slope of the curve differentiation.